All right, let's talk about something you've seen a million times, but maybe never really thought about. It's happening right there in your drinking glass, and believe it or not, it's a hidden scientific marvel. So, yeah, let's dive right in. Seriously, think about it for a second. You grab a glass, fill it with your favorite drink, and plop some ice cubes in. What do? They float, right? They just bob around to the top. We see this every single day. But have you ever actually stopped and asked, why? Why on earth do they float instead of sink? Well, it turns out that what seems totally normal to us is actually a massive scientific anomaly. I mean, a huge one. Water is a total rule breaker. And this little thing happening in your glass, it's one of nature's biggest and most important exceptions to the rule.
Okay, so here's the heart of the mystery. For pretty much everything else on the planet, when it gets cold and turns from a liquid to a solid, it gets denser. The molecules huddle closer together, It shrinks. Like a solid piece of steel would sink like a rock in molten steel. But water? Oh no, water has to be different. It does the complete opposite. When it freezes into ice, it actually becomes less dense. And that's why it floats. This is the big puzzle we're going to unpack.
So to figure out this bizarre, literally planet-shaping exception, we've got to go small, like really small. We're talking about zooming way, way down to the molecular level. That's where water is hiding its incredible secret. And here it is, the star of our show, the humble H2O molecule. You know the drill. 2 hydrogen atoms, 1 oxygen atom. Super simple, right? But here's the twist. The secret isn't just what it's made of, it's the shape. See, it's not a straight line. It's got this little bend to it. Kind of looks like Mickey Mouse ears. And that tiny, tiny detail, well, it changes absolutely everything. Because of that bend, the water molecule is a little bit like a tiny magnet. One side is a tad positive, the other side is a tad negative. And this lets them do something really special. They can form these things called hydrogen bonds. Just think of them as these weak, sticky connections that form between neighboring water molecules. This right here, this is water's secret weapon. So when water is a liquid, picture a mosh pit at a concert. It's total chaos, right? The molecules are all energized, jumbled up, sliding past each other, packed in super tight. And those hydrogen bonds we just talked about, they're constantly connecting and breaking, connecting and breaking. It's just this wild, disorganized molecular dance. But what happens when we turn down the music? When we lower the temperature? Well, the party starts to wind down. The molecules lose energy. They start to slow way down. And this is where things get really interesting. It sets the stage for this beautiful, orderly transformation. And it's such a cool process. Get this. At around 4 degrees Celsius, water is actually at its most dense. That's when the molecules in that mosh pit are packed together as tightly as possible. But as you cool it down even more toward freezing, that slowdown lets those sticky hydrogen bonds take over completely. They stop breaking apart. Instead, they grab on and lock all the molecules into place. And what you get is amazing. That chaotic mosh pit, it organizes itself. It forms this gorgeous, repeating, hexagonal crystal structure. It's like everyone in the crowd suddenly stopped, linked arms with their neighbors, and took a big step back. Now they're perfectly organized. But look, they're taking up way more space. There's all this empty room between them now. Okay, so we've got this new organized structure with a lot more empty space. So what? What does that have to do with our floating ice cube? Well, this brings us to the final, crucial piece of the puzzle, the simple science of density. Look, density is super simple. It's just how much stuff, or mass, you can pack into a certain amount of space. Think of it like this. If you just shove clothes into a suitcase, all jumbled up, you can probably cram a lot in. But if you fold everything perfectly and stack it, you might actually create empty gaps and fit less stuff in that same suitcase. You're less dense. And that is exactly what's happening with ice. Because that organized crystal structure has all that extra empty space built in, it means you have less stuff, fewer molecules, in the same amount of space compared to the liquid water. And if you have less stuff in the same space, well, you're less dense. Simple as that. So how much less dense are we talking? About 9%. That's the magic number. Ice is a whopping 9% less dense than the water it came from. And that isn't some tiny, trivial amount. That's a huge difference. It's enough to make even the most gigantic icebergs float around like they're nothing. All right, so we've solved the mystery in our glass. Cool. But this weird little quirk of water has consequences that are, well, they're anything but small. So now, let's zoom all the way back out and see why this little anomaly is absolutely essential for, all life on Earth. Think about it. Because ice floats, lakes and rivers freeze from the top down. That layer of ice on top, it's like a perfect winter blanket. It insulates the water underneath from the freezing cold air. And that's what lets fish and plants and everything else living in there survive the winter. On a planetary scale, our giant polar ice caps do the same thing, but for the whole globe. They act like giant mirrors, reflecting sunlight back into space and helping to keep our entire climate stable. Now, just for a second, let's imagine a world where water followed the rules. A world where ice was denser and it sank. What would happen? Well, every winter, lakes and oceans would freeze from the bottom up. The ice would sink, a new layer of water would freeze and sink, and on and on. After a while, our oceans would be solid blocks of ice, from the bottom to the top. Life as we know it would have never even had a chance. And all of that, our entire climate, every ecosystem, our very existence, it all comes down to that tiny little bend in a water molecule. It's incredible. So seriously, the next time you drop an ice cube into your drink, take a second to appreciate it. You're not just cooling down your drink, you're witnessing a life-giving miracle. And it really makes you wonder, right? What other huge secrets of the universe are hiding in plain sight, just waiting for us to ask why?